This Camtasia video is on cost crashing. When we crash a project, we want to reduce the overall time of a project. We do this by crashing one activity at a time. But we need to decide which activity is the best one or the least cost in order to speed up the project. If we look at the diagram, we can see the normal cost is low, but the time is high. The crash cost is high when the time is low, and that's the trade-off. In order to decide which activity should be speeded up, we use the formula for the cost slope in order to compare the activities. So we find the crash cost minus the normal cost divided by the normal time minus the crash time. Let's look at an example. So the crash cost is 2,000 minus the normal cost is 1,700 divided by the normal time is 5 minus the crash time is 2. This gives us 2,000 minus 1,700 over 5 minus 2, which is 300 over 3, which is 100. That means to reduce the project time by one time unit, it would cost us an extra 100. Now the activities that we crash must lie on the critical path because that's the only way we can reduce the time of the project. The non-critical activities are not important. It's a waste of time to crash these because they already have slack time and we'd just be adding to the slack time. This is a full example. So let's look at activity A. The crash cost is 50 minus 20 divided by 3 minus 2, which gives us 30. And the crash days available are 3 minus 2, which is equal to 1. So we can only crash activity A by 1 day. I've completed the remainder for you. So now let's look at the normal cost. The normal cost is the cost of doing all the activities in the project. So we simply add up the normal cost column, 20, 40, 35, 25, 20 and 5, and this gives us a total of £145. The network shows the diagram of this. So we have activity A, C, E and F. If we add that up, that gives us a total of 9 time units. If we look at the path B and D and F, that gives us 7 time units. Note I've put a red cross through F. That means we can't crash that activity at all. There are no days left to crash on that activity. And the normal cost of this project from the previous slide is 145. Bringing forward the information we calculated, we have the critical path as A, C, E and F, which I've highlighted in red, and these are the critical activities. So we can see that those are the ones that we can crash. So if we have a look at this, we can see that E has the lowest cost slope for the critical activities. So we pick activity E to reduce the time first. It costs us 10 time units to reduce the time by crashing activity E. And now we have a time of 8 days, and the project cost goes up by £10 to £155, and the critical path remains at A, C, E and F. E is now fully crashed because it has no days left to crash. It can only be crashed by one time unit in total. So here we're showing E is fully crashed, F is fully crashed, and we've put lines through both of those. If we look at the time now on the critical path, it's A is 3, C is 3, E is 1, F is 1, giving us a total of 8 time units. B and D and F is 7 time units. So in total, we are now on 8 days with a cost of 155. So what do we do next? Well, we look at the crash times and that's left on the activities, and we look at the ones that are still critical. And we have the critical activities of A, C, E and F still. So which one is cheapest? A is 30, C is 15, E is 10, F we can't do, E we can't do. So it's between A and C. C is the cheapest of the two between A and C, so we crash activity C next. By crashing activity C, it will cost us an extra 15, and that will add to our cost overall to give us 170. The project duration goes down to 7, and the critical path is A, C, E, F, and B, D, and F, because there are now 2 paths on 7 time units. Let's look at the network. So if we go A, C, E, F, it's 7 time units. If we go B, D, F, it's 7 time units. The critical path is of both those paths. The cost is now 170. But to reduce the time further, we must crash an activity on both paths. If we only crash on one path, the other path will remain at 7. So we could crash perhaps A and B together, and that would reduce the time down to 6. So A would go down to 2 and B would go down to 3. We're not going to do that. We're going to look at the cost slope to see which is the most effective use of crashing of activities. So looking at the cost slope, we could have done A and B, A and D, C and B, C and D, and those are the only combinations possible because E and F are fully crashed. If you look at the costs for those adding together, A plus B, A is 30, B is 20, we get 50. A is 30, D is 25, gives us 55. C is 15, B is 20, gives us 35. C and D together give us 40. So we can see that activity C is our cheapest one. So we need to crash activity C. If we crash activity C, we're going to reduce the number of crash days left to 0. So C will become fully crashed. And B will reduce down to 1. So crashing C and B together will cost us an extra 35. And it will bring our total project cost to 205, 170 plus 35, and the project duration will now go down to 6. We can now see C is fully crashed, and we've got a choice of A, B, and D to crash for the next one. So if we want to reduce to 5 days, then we'd have to crash a combination of A and B together or A and D together. Remember, it has to be one activity off each path. So A and B together is 50, A and D together is 55, and the cheapest one is A and B. So let's crash activity A and B together. A goes down to no time days left, and B goes down to no crash days left. So we then move on to the cost. The cost will increase by 50. The total project cost is now 255, and the project duration is now 5. All activities except activity D are now fully crashed, and we cannot reduce the time any further. Looking at the network, you can see A, C, E, F are fully crashed, B is fully crashed. If we reduce D by 1 day, it will reduce the path B, D, F to 4, but it won't reduce the path A, C, E, F. So we'll still be on 5 days. So we're now fully crashed. And looking at the cost against time diagram, when we had 9 days, it cost 145, which is down here. And you can see the cost increasing as the number of days reduces.